Hello everyone, this is the North America Math Let's go go go. Today in this video we'll be talking about the topic 11 of the book of the IB chemistry, which is going to be the first unit that you will usually learn about. So to start off, let's first talk about the difference between the precision and accuracy. During the English literature, if you like write compositions, you will definitely use those words interchangeably, which is normal in the case of general sense and English sense. But in terms of the chemistry sense, it is going to be different. So what's the difference then? The accuracy would be refers to the closeness of a measured value compared to the literature value. What is a literature value? Literature value means known value. So we basically it's a value of an object that is generally known and considered as correct. So for example, uh, let me think. So for example, like the value of the think. So for example, the value of the combustion of ethanol is equal to 1347 kJ per mole. The value of this is a value that is known and widely considered as correct. Therefore, it is considered as the literature value. Assume that we have a measure. Assume that we perform an experiment and we obtain a value of this. Since the 1346 is close to 1347, therefore it has a high accuracy. However, if I obtain a value of this is quite far away from 1347, therefore it has low accuracy. After knowing this, let's talk about the precision. The precision would represent the set of data that is that is close to each other, or it could also represent a single piece of data that has a high number of significant figures. Sig- a disclaimer here that the significant figure is going to be different than figure. The significant figure would refers to digits in measure value that carried meaning. But the definition of the significant figure, we don't need to know it at this point. You will definitely know it very soon, but not now. So let's. So now you can just you can just think it as figure. So assume that if we let's say if we have a like value of this single measurement is going to be this. This has a high number of figures, I mean significant figures, so that it would represent high precision. However, if we have single measurement of this, it would have a low precision because most of the digits remain unknown. And on the other hand, if we have set of data like this 0.99, 1.01, 1.03, we can see that those three sets of data are close to each other, therefore it has a high precision. And if we have a set of data like this, uh, like this, then it would have a low precision. Knowing this, you can see that there's a difference between the accuracy and precision. So I'm going to give you a few questions then. Let's say we have a literature value of 3.98. So two students, they obtain two different values, which is going to be 3.99 and 100. 4, let's talk about this. 4 and then this. Comment on the precision and accuracy of the two values. So basically, by looking at them, we can see that A is quite close to the literature value. Therefore, A has a high accuracy, but A has quite a few digits, aka significant figures. So therefore, I mean, A has quite a few like significant figures. So therefore, it would have a low precision. But if you look at this, you can see there are many like digits, significant figures. So therefore, we will have high precision. However, this value is quite away from the literature value, therefore it would have low accuracy. Okay, so after knowing this, the next thing that we are going to do is going to be talking about uh, significant figures. So to start off, what is significant figure? So, um, so let's talk about the significant figure. So first of all, the significant figure would be defined as digits in a measured value that carry meaning, and digits in a measured value that were actually measured. And there are a few different rules deciding which digit is significant. So rule 1 is going to be all non-zero digits are significant. For example, if we have a value of, let me think, 167, as 1, 6, and 7 all carry meaning and all are actually being measured, therefore it would have three significant figures. Because look at this, 1 is one significant figure, 6 is two significant figure, 7 is three significant figure. So therefore, this thing would have three significant figures. Rule 2 is going to be the number of zeros on the left of a decimal place is not significant. For example, in this case, since this thing is like the left of the decimal place, this is 1. Those things are all not significant. Therefore, it would have only one sig fig. And if we do another example, this thing, we can see that this is a decimal place, this is a 3, and there's zeros on the left of this. So therefore, it's also not significant as well. So in this case, we would also have one sig fig. Now let's talk about the third rule, which is going to be zeros between the significant figures are not significant. Between significant figures. So for example, if we have a value of, let's say, this wonderful person completes the IB diploma with the final score of this. So you can see that there's 0, but we can see that there's a 1 that is a significant figure, and there's also a 1 that is a significant figure. Therefore, those zeros inside the two ones are also significant as well. So in this case, all of those digits are significant. Therefore, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 significant figures. Let's talk about the next thing. Zeros on the right of a significant figure are not significant. So what does it mean? For example, if you have a number like this, right, 300, since those zeros are all on the right of 3, which is a significant figure, those zeros are all not significant. Therefore, the only significant figure would be 3, hence would refer to one sig fig. And then it's another rule. It's like in scientific notation, all digits are significant. In scientific notation, the digits to the left of 10 to the power of n is significant. So for example, if we have this, right? In this case, both 4 and 0 are significant because they are to the left of this. So in this case, this would have two sig fig. However, if you modify it slightly and write it in this, you can see that there's only one sig fig to the left of 10 to the power of n, which is going to be 4. In this case, there's only one sig fig. Okay, so after knowing about those rules, just give me a second. I'm just checking whether I have talked about all the rules here. I think I have. So after talking about all those rules, we can now try doing some problems here. But before that, I find out that we still need to talk to you about some rules of multiplication and addition of significant figure. For the addition and subtraction significant figure, it is a bit different than multiplication and division. So we are going to talk about addition and subtraction first. So the addition, the significant the significant figure of the final answer would be the same number of significant figures as the significant figure of the final answer would be the same place value of the least precise significant figure. This may seem very confusing, so we are going to do this to show. I'm going to do this to show you. Let's say we have this, right? 33.7 plus 195.45. What we are going to do is we are going to place it 195.45 plus 33.75. Based on this, you can see that the two values, they are the last place of their place location are the same, are lined together. So in this case, the final value is going to be 5 significant figure, which is 228.229.20. However, if I give you another example, 33.5 times plus 195.4, it would be 33.75 plus 195.4. In this case, you can see that the one on the bottom only has the place value up to like one significant figure after the decimal, while this one has two significant figure if you place it. So therefore, its answer would be only up to the first digits of the on the right of decimal, which means it would only have four significant figure in this case. So it would be 229.1 instead of 229.15. Okay, so compared to the addition and subtraction, the multiplication and division are relatively simpler. Basically, they are just basically you just round the final answer to the value with the least amount of significant figure. So for example, you have this times this, right? If you just put this let me put it in this way. If you just put this random thing in the calculator, you're able to get 1441.125. However, the thing is that you look at the two values. This one, it has four significant figure. This one, it has three significant figure. Therefore, the value would be rounded up to here. In this case, it would be 1440. Okay, so let's do some practices now. For example, I'm going to give you a few questions in this case. 375.5 times 1.7. Identify the significant figure of the following. P is going to be 357. So let's look at those problems individually. I'm going to give you a few seconds. If you want to try the solution, you can pause it. Pause the video. So looking at the first question, this one has 5 sig figs, this one has 2 sig figs. Therefore, the final answer should be in 2 sig fig. If we plug this random thing into the calculator, you are able to get 638.503, which would obtain to 640 up to 2 sig fig. So for this one, therefore you would have 2 sig fig. This one is easy, 3, 5, 6, 8. Therefore it has 4 sig fig. This one, the numbers to the left of the decimal place would not be counted as sig fig. So therefore they are not sig fig. Therefore only 9 is sig fig. So significant figure. Therefore only one significant figure. This one would be the second one. On the left of this, it doesn't count. This one, it counts. This one, it counts. This one, the 3, it counts. The 0, since it is between 9 and 3, it also counts. Therefore, the significant digit would be 903, and hence would be 3 sig fig. This one, 9 counts as sig fig. 3 counts as sig fig. 0, it is between 9 and 3, so it also counts as sig fig. Therefore, it will have 3 sig fig. And finally, we are going to talk about the 9.0 times 10 to the power of 12. For this value, since the 9.0 is on the left of 10 to the power of 12, therefore all the digits of 9.0 will be counted as sig fig. Therefore, it will have 2 sig fig. Okay, so now let's talk about the SI system. Basically, the SI system is quite simple. I'm just going to, all you need to remember is the conversion factor, and you are able to convert it back. Let me just grab a table here. So, for this one, I'm going to tell you that there will be a table like this. Conversion factor to the standard unit. And would be ECM. And it's micro, with micro. Micro is this one, micro, nano, pico. So this would be conversion factor to the standard unit. So basically, if you want to calculate the what I call the SI unit system to a standard unit, all you need to do is multiply it by a conversion factor. So for example, if we have like, let's talk about easy one. If you have 10 kilometers and you want to convert to meter, basically just multiply it by the conversion factor, which is 10 to the power of 3. So this is going to be this. And on the other hand, if you want to convert 10 millimeter convert to m, you will just multiply it by the conversion factor of 10 to the power of negative 3. You will get 10 to the power of negative 2. Okay, so basically, in doing this, you will be able to know the how to convert it. And yeah, just try to practice this one and hope could have a good understanding about it. And we are just going to end our first part of the chapter 11 here. In the next video, we're going to talk about the second part. The second part will talk about some other concepts, which includes uncertainty, random and systematic error, and the literature value versus what's that called experimental value. Here we come to the end of our lesson and hope you have learned a lot. See you next week. Bye bye.